It'll be all right. All right, so let's go back to this problem. Okay, so I have the raw data. Again, it's not given to me, but I can find the sample standard deviation. The fact that this is about a mean and I don't have the population standard deviation, I know that I'm going to do a t interval. I still really need the sample mean, but Minitab is going to calculate that for me. I still need the sample standard deviation. Minitab is going to calculate that for me. I can figure out my sample size. It tells me in the problem we had 12 subjects, or I can count the number of values I have. And my confidence level is 95%. That's given to me in the problem. It says 95% confidence interval.
You're not screen
Oh,
sharing.
thank you, ma'am.
You're welcome.
Okay, so let me walk back through that. Okay, remember the sample mean is not given, but Minitab is going to calculate it because I have the raw data. The sample standard deviation is not given, but I can calculate it from the raw data. Minitab is going to do that for me. It does tell me I had 12 subjects, or I can count how many values I have, and it clearly tells me to do a 95% confidence interval. So I need to go out to Minitab, and I've got to enter these 12 values. Okay, so I'm going out to Minitab, and I'm going to put in, what are these values? These are hours slept, number of hours slept. And I'm going to enter that data. So we have 8.2, 9.1, 7.7, 8.6, 6.9, 11.2, 10.1, 9.9, 8.9, 9.2, 7.5. Whoops, I missed the decimal there. That'd be a long time to sleep. 7.5 and 10.5. So I corrected my error. Okay, I'm going to double check, make sure I don't have anything else too wonky. Okay, so I have the data entered. Now I'm ready to do the calculation. We go to Stat, Basic Statistics, 1 sample T. My sample size was, oh, I'm sorry, we have sample-rise data. I got to tell it I have 1 or more samples each in a column, because I know I have 12 samples, but I don't know the other information. So I have the raw data, so it's 1 or more samples each in a column. Where is the data? This is number of hours. Options. It is a 95% confidence interval. Tells me that in the problem. The alternative hypothesis is always not equal. Click OK and OK. And I get my information. Now again, remember, with this information, Minitab is also going to give you the mean. See, it's calculated the sample mean. It has calculated the sample standard deviation. So should you need it, remember Minitab has calculated those things. So from Minitab, I now know the sample mean is 8.983. I get that from Minitab. It also calculates my sample standard deviation, which is 1.290. 1.290. Again, that comes from Minitab. Remember, we don't need the SE mean, but my confidence interval is given here. And again, I can clearly identify my lower bound, which is the first number in the parentheses, which would be 8.163. The upper bound is 9.803. And then usually the next question is, what is your error bound for the population mean, which is a hand calculation. It is your upper bound minus the lower bound divided by 2. Again, that is a calculation that you have to do for yourself. It's plugging and chugging. So I would have 9.803 minus 8.163. Again, I put parentheses around that to emphasize that you need to do that subtraction first. So I'm getting my calculator. 9.803 minus 8.163 is 1.64 divided by 2 is 0.82. So the error bound for the population mean is 0.82, not quite a full hour. The last step is to write the conclusion. And we say, we estimate with 95% confidence that the true population mean number of hours slept is between 8.163 hours and 9.803 hours. Guys, it's the same process. It's just that we're doing T because we do not know the population standard deviation. Now, for T, we do not do a sample size estimation for T. T, the student's T distribution, is intended to be used with smaller samples. So it could be smaller. So we don't worry about calculating the sample size for a T interval. So now let's look at the last option, and the last option is where you have a proportion. Okay, instead of the mean, we're going to deal with proportion. So the idea of proportion, it could also be stated with percentages. So you have to be careful as you're reading the problem, because these problems are going to probably talk about proportion or a percentage as opposed to a mean. But the idea behind them are the same. Now, I mentioned to you earlier that when we were doing the Z interval, whoops, misspelled that. The Z interval, we're doing a confidence interval for the mean where we know the population standard deviation. And that is connected to or related to the normal distribution. I just told you when we're doing the T interval, it is related to the mean, but we do not know the sample standard deviation. We know the sample standard deviation, and that is related to the student's T distribution. When you're thinking about the confidence level for a proportion, okay, the underlying or the background distribution that's taking place is a binomial distribution. Okay, it is based on the binomial distribution. And again, in the scenario, there will be no mention of a mean or an average. There'll actually be even no mention of a standard deviation. Okay, but it's based on the normal, based on the binomial distribution, where we think about the number of trials. How many times do we do the experiment? That's sort of like your sample size. And we look at the probability of success. What's the chance that that particular thing is going to happen? Again, the formulas are slightly different, but Minitab's going to do the work for us. The formula, you do have to do a couple of calculations by hand. It's called the point estimate. This is your sample proportion, which is comparable to your sample mean, and it corresponds to how many do you have in the specific category that you're looking for divided by the sample size. Okay, that's like your sample proportion, and this is what we would call a success because we're getting what we want. If you have a success, then you also have the opposite, which is the failure. Failure is 1 minus P prime. I got a symbol missing there, sorry. So the two together, when you look at it, your success plus failure have to total to 1. So P prime plus Q prime have to total to 1. Because remember, 1 in terms of probability means something's going to happen. And then we change the notation. It becomes error bound for the proportion E, B, P, because now we're talking about a proportion, not a mean. So the notation changes just a little bit. And it is actually a Z interval. Okay, it's called a Z interval. In this scenario, you're going to have to be told the number of successes. How many are in the category that you're interested in? You're going to have to be told the sample size, how many were in the sample total, and then you have to be told your confidence level. And for these problems, you're only given the summarized statistics, okay, or summarized data. You will not have raw data. The keystrokes for Minitab are on slide 5. Okay. Keystrokes for Minitab are on slide 5. You still have to manually calculate the error bound for the proportion using the information from Minitab. Again, it is not a calculation that Minitab does, but the formula is the same. It is still the upper bound minus the lower bound divided by 2. The statement of your conclusion is the same, except we use the word proportion instead of mean, because now we're dealing with a proportion or a percentage. Same concept, slightly different information. Okay, so then we're going to take a look at some examples. So I'm going back over to our Word document. And this one says, suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they have cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of this city who have cell phones. Okay, so as I was reading through that problem, one of the things that I noticed, there's no mention of the mean. In fact, several times it uses the word percent or the word proportion. Okay, it does clearly tell me that we're doing a confidence interval, but again, I have to recognize that it's a confidence interval for a proportion or a percentage. There's no mention of the mean. There's also no mention of the population standard deviation or the sample standard deviation. So again, those are all kind of clues, red flags. This is not a problem related to the mean. So I realize that I need to create a confidence interval. Whoops. Confidence interval for a proportion, which is actually a Z interval. To do that, I need X, N, and the confidence level. N is basically your sample size. X is what we call the number of successes. And in this case, a success is that they have a cell phone, because that's what I'm interested in. And then, of course, CL is the confidence level. Guys, all of that is given in the problem. If I go back and read, it says 421 people responded, yes, they own cell phones. So I had 421 successes. And I sampled 500 people were surveyed. So there were 500 people in the survey. And my confidence level is 95%. Everything I need is given in the problem. My challenge is recognizing that it is a proportion, not a mean, and that will help me to identify what command to use. So I'm going out to Minitab. I go to Stat, Basic Statistics, 1 proportion. And now I'm doing a proportion, 1 proportion. I have summarized data. The number of events is my sample, number of events is my number of successes. Let me go over here and make a note for you. Minitab calls the number of successes, Minitab calls that the number of events. N, Minitab calls the number of trials. Okay, so you don't get confused by the language. Okay, so the number of events, I had 421 people say, yes, I have a cell phone out of 500. Go to options. I am doing a 95% confidence. My alternative hypothesis is not equal. And then the method, we always want to use a normal approximation. Okay, for the method, we want to do a normal approximation. All the time when I'm doing a proportion. I click OK. I click OK again. And it gives it to me. I do have to scroll down a little bit, but it does give it to me. Okay, so I'm going to copy this. Okay, so it tells me, again, N is my sample size. Event is my number of successes. Minitab does calculate for you this sample P. This is your P prime that I mentioned to you a while ago. My sample, the sample P is your P prime. Here is my confidence interval. Again, it's in the parentheses. So I have 0.810030, comma 0.873970. The first number in the parenthesis is your lower bound. That's the smallest proportion it could be. The second number is your upper bound. Again, the questions will be formatted the same way as you had before. Okay, so you're going to have a question that says, you know, what is your lower bound? So you would write down the number 0.810030. Then what is the upper bound? 0.873970. Those answers, just as before, come directly from Minitab. I then need to calculate the error bound for the proportion. The formula hasn't changed. It is still upper bound minus the lower bound divided by 2. But again, it is a manual calculation. I have to do the calculations on the calculator. So I have 0.873970 minus 0.810030. Again, guys, you have to follow order of operations. You will do the subtraction in the numerator first. So I have 0.873970 minus 0.810030. I'm using my handheld calculator, which gives me 0.06394. I'm then going to divide that by 2. Whoops, I hit the wrong number. Divided by 2 gives me 0.03197. So the error bound for my proportion is 0.03197. Now, these answers here, just so you'll know, these are in decimal form. I could convert them to a percentage. But to remember, to convert to a percentage, we multiply by 100%. But the question asked me for proportion. Okay. So since it says proportion, that usually means leave it as a decimal. So writing my conclusion, we would say we estimate with 95% confidence that the true population proportion, let me pick up my variable, of adult residents in this city who have cell phones is between 0.810030, which as a percentage would be roughly 81%, and 0.87970, which would be roughly 87.4%. Now you don't have to add in the percentages, but I wanted to show it to you. Guys, it's the same process with slightly different commands in Minitab. Now, I have another example, but I want to show you how to do the sample size estimation before we run out of time, because we only have about 24 minutes left. Okay, and if we have time, I'll come back and do that second example for you. Okay, but we can also estimate the sample size, because this is technically a Z interval. So I can do the Z interval for the mean or the Z interval for the proportion. I can provide a sample size estimate. I'm still using that same table that we had earlier to determine my critical value. Okay, it's the same table. That table is provided on the test. The formula looks a little bit different because now we're dealing with a proportion. In this formula, the Z alpha divided by 2, that is your critical value. That critical value comes from the table. And notice that value is squared. P prime is your sample proportion. And I just showed you that Minitab calculates that. Q prime is the 1 minus P prime. Okay, you will have to calculate that. Remember, the sample proportion is your success. The Q is your failure. And then EBP squared, okay, again, you're going to square it, but this is your margin of error for the proportion. Okay, so it's a pretty yucky looking formula, but guys, all of the information is either given in the problem, on the table, or can be calculated. You just have to be a little patient. Okay, so I want to work an example of this first so we don't run out of time. And then we'll come back and look at others if we need to. It says, suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 or older should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points of the true population proportion of customers aged 50 plus who use text messaging on their cell phone? Okay, couple of things to note here, guys. Notice again in this problem, there's no mention of the mean. In fact, several times it uses the word percentage or proportion. The other thing that jumps out at me as I'm reading through this problem is it says, how many customers? Which kind of gives me the clue that I need to do a sample size estimation. Okay, so that's my clue that I want to do a sample size estimation. And again, I'm doing a sample size estimation for a proportion because the problem itself has no mention of the mean. So to do that, I need my critical value, which is going to come from the table, and it's based on the confidence level, which is 90%. I'm going to go back to the PowerPoint because it's easier to get to and look at my table. Okay, 90%. My critical value is 1.65. Okay, so my critical value is 1.65. I also need P prime. We'll talk about that in just a minute. Okay, which is my proportion for success. Q prime is my proportion for failure. And we need the error bound proportion. Okay, so remember this is the margin of error, which should be given in the problem. So if I go back up here and I look, it says is within 3 percentage points. Okay, but guys, be careful. That's 3%. My percent as a decimal would be 0.03. Okay, be careful. 3 percentage points. Now, you may be a little confused because it doesn't talk about in the problem how many, obviously it doesn't talk about how many we sampled. It doesn't talk about your proportion of people who are age 50 or older that use text messaging. It doesn't give us that information in the problem. Okay, so here's what we do. Okay, if it's not given, if you are not given the proportion for success, okay, if not stated in the problem, the rule is we use 0.5. We default to the fact that it could be 50% because there's 2 options. They either use it for texting or they don't. So there's 2 options. So I have a 50-50 chance that they do. So if the proportion for success is not stated in the problem, you will by default always use 50% or 0.5. Okay, so that means for this problem, because it's not stated, my proportion of success is the 50%. My proportion for failure is 1 minus the proportion for success. So 1 minus 0.5 is 0.5. So in this case, my proportion for success and my proportion for failure are the same, and they're both 50% because it is not stated in the question. So this one's a little bit trickier because you have to get that information converted to decimal form, but then it becomes a straight, flat out substitution problem. Now this formula looks a little bit messier. Okay, so the formula is the sample size should be your critical value squared times the proportion of success times the proportion of failure divided by your margin of error squared. It's a plug and chug. So I would have my critical value is 1.65 squared. My proportion for success, because it is not stated, defaults to 0.5. That also means that my proportion for failure is 0.5. And the error bound for the proportion that's given in the problem is those 3 percentage points. Now here again, guys, you have to follow order of operations. Okay, you gotta follow order of operations. So I'm going to start with the numerator, and I would do the squaring first. So 1.65 squared is 2.7225 times 0.5 times 0.5 times 0.03 squared. Now I'm walking it through. Again, following order of operations, I would continue to work in the numerator. So 2.7225 times 0.5 times 0.5 equals 0.680625 divided by 0.03 squared. I've finished all of the calculations, whoops, in the numerator. Now I'm going to deal with the denominator. So I need to square the value in the denominator. So 0.03 squared is 0.0009. Now I'm ready to do the division. So 0.680625 divided by 0.0009 equals 756.25. Here again, we use the same guideline that we had earlier because we are thinking about people or items that have to be whole units, and to ensure that we meet the margin of error, we will round up regardless. So this becomes 757. So I would need to survey 757 people in order to ensure that I have a 3 percentage point margin of error. Now, I only had one example of that, but let's see if I can create another one, because that one tends to be a little bit trickier. Okay, so let's go over here. I'm going to use this example, and let's say wants us to compute using a 90%. Okay. let's see, how many students are needed for a margin of error of, let's say, 5 percentage points. Okay, again, I'm making up this problem so that we can have a second example of the sample size estimation, because that formula is a little wonky. Okay, so this problem says community college retention is a commonly researched subject, with colleges wanting to understand the percentage of students who will remain enrolled each year. One survey found that 670 out of 1,000 students returned the following year. Using a 90% confidence level, how many students are needed for a margin of error of 5 percentage points for the true proportion of students who returned the following year? Okay, again, looking at this problem, there's no mention of the mean. Okay, it does a couple of times use the word percentage or the word proportion. So that's my first clue that it's a proportion problem. It also asked me, in terms of the question, how many students? So that statement lets me know that I'm looking for the sample size estimation. And again, it's the sample size estimation for the proportion. To calculate the sample size, oops, sorry about that, the sample size for the proportion, thinking about my formula, I need my critical value, which is going to come from the table, and for this problem will correspond to 90%. I need P prime, which is my proportion of success. Q prime is my proportion of failure. And remember, it's always equal to 1 minus P prime. And then I need my error bound proportion, okay, which is your margin of error. So let's see if we can identify those things in this problem. Okay, so I'm going to use my table that's on the PowerPoint. Again, 90% is going to be 1.65. Okay, so my critical value, again, for this problem, because I'm doing 90%, is 1.65. I'm going to go ahead and do my error bound, or my margin of error. Ms. Ralston made it up, but the margin of error is 5 percentage points. Okay, so 5%, convert it to a decimal. Remember, that's 5 divided by 100, which is 0.05. Now, this problem actually gives us information about the proportion of success, because it says one survey found that 670 out of 1,000 students returned the following year. So this statement is my P prime. It's my proportion of success. It tells me that I had 670 out of 1,000. I can convert that to a decimal. Okay. Minitab would do it, but I'm just going to do it on my calculator. 670 divided by 1,000 is 0.67. So the probability of success, or the proportion that returned the next year, was about 67%. If my success is 67%, I then have to calculate what my failure is going to be, which would be 1 minus the 67%, whatever's left. 1 minus the 67% is 0.33. Okay, so this problem is, again, just a little bit different because it gives you that proportion of success. And if it's given, we use it. If it's not, we default to the 50%. Now I've got 3 minutes. So let me see if I can plug and chug into this lovely, lovely formula. So again, we have N equals the critical value squared times P prime times Q prime divided by the error bound for the proportion squared. Plug and chug. So I have 1.65 squared times 67% times 0.33 or 33% divided by the 0.05 squared. Okay, again, make sure you follow order of operations. So I would square 1.65 first, which gives me 2.7225 times the 0.67 times 0.33 divided by the 0.05 squared. Perform the multiplication in the numerator. So 2.7225 times 0.67 times 0.33 is 0.60194475. Now square the value in the bottom. 0.05 squared is 0.0025. Now do the division. 0.60194475 divided by 0.0025 gives me 240.7779. Again, we always round up, so this would round to 241. Now, I've only got a minute left, so I've run out of time. Okay, so here's the plan. That finishes the content for Module 2. It finishes the content that's going to be on the midterm. I hope you will take some time and look at the midterm review sheet that's posted in the announcements before Wednesday. On Wednesday, I would like to spend time doing additional examples of confidence intervals if need be, but also answering any questions that you may have related to the material that's going to be on the midterm. Questions?
No questions.
Okay, I hope I didn't mess up. I hope we wind up with 2 recordings today because I turned off the first one before I was supposed to. If not, I do have an old version of the lesson that I'll post so that you'll have the entire lesson. Okay. And I will look forward to seeing you guys on Wednesday.
Okay.
Y'all have a good afternoon.
You too. Bye.
Bye.
Bye.